Alrighty, we are going to do a problem here called dynamic array, design dynamic array. This is on neatcode.io. They have some good practice problems for interview type questions, algorithms, data structures, stuff like that. So let's read the instructions here. This one is supposed to be easy, so we'll see how that goes. And we'll see if we can get through this quickly. All right, so design a dynamic array, aka a resizable array class, such as an array list in Java or a vector in C++. So just worth noting that in terms of implementation, they give you a couple options. You can do Java or C++ or JavaScript or Python. I know neither of Java or C++, but I do know Python and JavaScript. So we will do this in Python. All right, your dynamic array class should support the following operations. So it's got 1, 2, 3, 4, 5, 6, 7, 8 different operations. The first one is dynamic array. This is the invocation of the actual array class, and it takes in an argument capacity as an integer. And this will initialize an empty array with a capacity of capacity, where capacity is always going to be greater than 0. And then let's see here, there's a get method that returns an integer. It takes an integer with the argument or the parameter of I. This will return the element at index I. Assume that index I is valid. Another one for insert. This will insert the element in, which is the second argument, at index I, which is the first argument, both of which are integers. Assume that index I is valid. Now, when I was going through this, I just thought like, oh, just looking at the problem, I was like, oh, we're just basically recreating arrays. So when you insert, actually, now that I think about it, I'm not even sure that my assumption was correct. I was thinking initially that when you insert a value in an array, that it shifts all the other values to the right by 1. But I could be wrong. It could be that the insert method that I'm thinking of actually does overwrite the value. In any event, in this particular use case here, instance, when they say insert this value at this index, they're saying overwrite the current value at that index, if there is a value there. So there would be no shifting of the other values. Like if there was a value at that index, it would just get overwritten. It wouldn't get shifted to the right. Another method here, pushback. This one takes a integer value of n, will push the element in to the end of the array. So this is essentially like a push method or an append method if you're writing Python, push if you're writing JavaScript. I think in Ruby it's probably also push. Another one here called pop back will pop and return the element at the end of the array. Assume that the array is non-empty. And then we've got another one here called resize. By the way, anywhere where you see void on the left-hand side, this syntax just tells you that that particular method is going to return the equivalent of void. I don't know what language that would be in, but let's just say in Python, it's like none, or in JavaScript, it's null. So just whatever data type represents nothing. In Ruby, I think it's nil. All right, so what was that? Resize will double the capacity of the array. So this one, the first time I went through this problem, I misread it. I just thought, oh, resize, I'll just add one more value. I missed the keyword double. So like in reflection, after doing the whole thing, I went back and I realized, oh my gosh, you have to pay super close attention to every single instruction. Definitely take the time to read and reread and document pseudocode, whatever you need to do to make sure that every little step that you're working on, you're doing it exactly like the requirement asks you to do it. Another one here called get size is going to return an integer. This will return the number of elements in the array. And then get capacity will return the capacity of the array. If we call the pushback method, but the array is full, we should resize the array first, meaning we should invoke the resize method that we defined first. So here's some examples. Basically, the way that they do the input is kind of interesting, but they have a list of strings and integers and null values. And it's anytime you have like a method then it takes whatever number of arguments after it. And then the output is just the result of that gets pushed into this output list. So for example, when we create a new array with a capacity of 1, then the return value is just going to be null. Nothing happens. It just creates this new empty array. And then when we call get size, it's going to say, hey, the size of this thing is 0, meaning there's no elements inside of it. But then when we call get capacity, we set the capacity to 1 whenever we initialized the array variable and instantiated the new dynamic array. And so therefore the capacity is going to return 1. So that's how you can read the output versus the input. And if you go through, they can do like, if you go all the way to example 3, you'll see they do like a number of different operations with these various arguments. And then you get whatever the output is gets pushed into this output list here. Okay, there's a note here at the bottom. The index I provided to get method and insert method is guaranteed to be greater than or equal to 0 and less than the number of elements in the array. So basically, all these little notes in here are just saying that this thing is, there's not a lot of edge cases that you have to worry about. In fact, I don't think there's really any. It's saying, if we tell you to put a value in there, then you know that it's going to fit in the array. Or if we tell you to take a value out, then we're doing it knowing that there's already a value to be taken out. You don't have to handle the edge cases there. So let's start at the top. In our Python here, we have a class dynamic array. By the way, this is all, whichever language you choose, it's going to give you a bunch of code in here. For whatever reason, they put these little doc strings on the JavaScript implementation, but not the Python. But anyway, you can do it if you're familiar with Java or C++. Those could be the languages that you could use to solve this problem as well. So this is our dunder init method, right? This is our constructor function that gets called every time we invoke this class and we create a new instance from it. And so this takes self, and then it takes something called capacity, which is expected to be an integer data type. And based on our kind of our pseudocode over here, you can bring this over here if you want to. This will initialize an empty array with a capacity of capacity where capacity is greater than 0. So the first thing is we need to set the capacity. So we have access to self. We're going to say self.capacity is equal to capacity. So that is based on the argument that gets passed in to dynamic array when dynamic array is invoked. Great. Now there's an additional step where we need to keep track of the size of the array. And this, we'll see where this becomes useful later. And the reason we're keeping track of it rather than just like calling the len method is because we want to avoid using these built-in array methods. The kind of the whole point of this is that we're building our own array class. And so we want to, whatever we can do from scratch, we're going to go ahead and try to do that. So let's say self.size is equal to, I think these are always going to start at 0. It doesn't matter if the capacity is 10. Until we start inserting values, the size is always going to start at 0. The next thing is the actual array. So generally in programming, if we're calling something an array, we want to avoid overriding any predefined variable names. I don't think array is already claimed in Python. They use something called a list, but we're going to avoid it anyway. So we're just going to call it ARR for short. So self.arr is equal to, and we could do just this empty list here, but the way, and I think that would actually work. The way the solution does it, whoever wrote this, the guy that made the website, he makes it to where there's like a predefined number of basically 0 values living inside of this list. And then that way you can overwrite these values as needed. And that helps to where we don't have to rely on any of the built-in list methods whenever we're dealing with some of these operations later on. So the way that we do that is we put a 0 in here, and then we just multiply it by capacity. And so let's say capacity is 4, then what you get is a list with 4 elements, all of which are 0. That syntax should be correct. Of course, we'll test it later. All right, so I think we're good here for our dunder init. The next thing that we want to deal with is our get method. So let's go down to get. We'll go ahead and borrow this. and plug it in as a comment. This will return the element at index I. Assume that index I is valid. So if we're assuming that index I is valid, then we don't need to check and see if index I is valid. So we know that we have self.arr, and we know that we can use square bracket syntax, bracket notation, to access elements inside of a list in Python at their index. So here we should just be able to say self.array I, and then just return whatever value that gives us back. So that's what we'll do there. The next one is going to be insert. This doesn't return anything. It simply inserts an element in at index I, and then it just assumes that the index I is valid. Again, there's no need to check whether or not index I exists. This is telling us that we can assume that it does exist. So when you don't return anything in a Python method, many of you probably already know this, you implicitly end up returning none data type. And because this is expecting void, none is essentially the equivalent of void. We don't have to return anything, but we do need to do some operation here. So we need to insert the element in at index I. So we just need to say self.array at index I is equal to, so we're just overriding whatever that is at index I with value in. Now, if we want to then get that value, we would just call .get. So we're not actually going to return anything from the insert here, other than the implicit none that gets returned. All right, push back. We'll push element into the end of the array. All right. Cool. So obviously, in Python, we would just use .append, but again, we're trying to avoid doing that. And so a couple of things are going to happen here. Let's just assume that our list is empty. Okay. Or not empty, right? Because the way we initialized it is we said like 0 times capacity. So let's say our capacity is 1. We currently have a value of 0 here. And so then our size is equal to 1 and our capacity is equal to 1. Okay. And I'm sorry, our size starts at 0. Our size starts at 0. Our capacity is 1. And so we need to push an element to the end of the array. So we want to put the element at the index of, in this case, 0. And that would be the length of the array. Now, I'm getting a little confused in my head about size and capacity. I'm trying to decide which one, and we could just experiment with both to try and clear things up. But I'm trying to figure out which one we would use. So like, let's say we have self.array. And if we did self.size is equal to in, and self.size is 0, then in is going to live here. So if in is like 6 or something, then now this value will be 6. So that'll overwrite that. Let's see what happens when let's say we have multiple values. So we have like 1, 2, 3. And so at this point, size has been incremented to 3. Capacity started at, let's just say that capacity started at 3. So we didn't have any concerns there. So size is 3, capacity is 3. And now if we do self.size is equal to in to put a new value there, then so that's actually not going to work. Oh, let's go look at pushback. Here at the bottom, there's a note. If we call pushback, but the array is full, we should resize the array first. So at this point, the array is full in this example that I'm giving. And so if we did self.size, that's out of bounds. It would assign the variable it would assign the value in at a index that is out of bounds on this particular list. Not if we resize first. So let's go implement resize, and then we'll come back up here and finish the insert. So resize will double the capacity of the array. So if we say, let's think about this. We can double the size of the array right? So like, let's say we have 1, 2, 3, and the capacity is 3, right? Capacity is 3. And at this point, size is also 3. And we want to double the capacity. So capacity needs to turn to 6. But if the capacity turns to 6, then we should have 3 new places in here to store new values that get either inserted or pushed, right? If it gets pushed, it gets put in this very last placeholder. If it gets inserted, it can be inserted into any one of these. The way that we can do that is we can essentially create a brand new array, right? So if we said something like new underscore ARR is equal to, and we use that same syntax that we used up here, and we multiply a list with 0 element inside of it times the capacity. First, of course, we have to update the capacity. So we say something like self.capacity is equal to, and then we want to double it. So 2 times self.capacity. And so then here we would, now we want to access self.capacity. So this new array would ultimately be like 0, 0, 0, 0, 0, 0. So that's fine, except we need access to those original values that we had in there, right? And so, by the way, new array is just some variable that we've defined. So we haven't actually overwritten self.array. So self.array still looks like this, and the new array looks like this, and we want to combine these two. So let's do a, oh gosh, let's do a for num. Let's not do a num. Let's do for index and value in enumerate. And let's enumerate over self.arr. So if ARR is 1, 2, 3, then we should get 0 matched to 1, 1 matched to 2, and 2 matched to 3. And that'll be helpful for us to have those indices. Gosh, I guess the values aren't super useful. Anyway, let's just do it this way at first. We can optimize it maybe using like a range or something, but I don't want to get my head all mixed up. So currently we have new array, and we can say new array at I is equal to, and we have the value, so let's just assign the value. And now because there's only 3 elements here, this for loop is only going to happen 3 times. It's going to happen for 0, 1. So here's 0 on new array, which is a 0. It's going to be replaced by value of 1. And it's going to do that for 2 and 3 after that. So then new array becomes the array that we want it to be. So then when it's done running, we should then be able to say, okay, now we can overwrite self.array with the new array. All right, let's get rid of some of this. I love that his editor here has all my keyboard shortcuts. Must be some type of like VS Code implementation. Anyway, so the first thing we do is we double the capacity of the array. So we say, hey, the capacity is equal to 2 times itself. And then we create a new array using that capacity. So let's get rid of this little example at the end here. And then we iterate over the enumeration of the original, the current state of the array. That gives us the index and the value. You could use a range just to get the index. Probably a little more optimal, but I'm not super worried about it. It's going to have the same outcome here. So then you say new array, which is all zeros, at index I is equal to whatever this value is in self.array. So that essentially combines the self array with the new array. And then we say, okay, now update self array with the new array. So we've resized and we've updated the self.array such that it has these placeholder values of zeros for the spaces that we can allow additional elements to be inserted or pushed back. All right, so with that information, the first thing we want to do up here is check if the size equals the capacity and resize if so. So we'll say if self dot size is equal to self dot capacity, meaning there's no more space left inside of this list. Like this is maxed out, right? Size of 3, capacity of 3. We're trying to push an element in here, but we'd really like to, the method that we're going to use to push it or append it would be to overwrite whatever value at the end of this list. And so we're going to double the capacity. So here we're going to say self dot resize. And oh, interesting. So right now I'm calling self.size and self.capacity. This is fine. It works, right? These are values that we have. These are attributes on this object. Technically, we're defining getter methods, get size and get capacity. We haven't implemented them yet, but we could also refactor this to call these as get size, get capacity, and get size. It should work either way, but we can come back to that. Okay, so once we've resized, then we want to push, oh gosh, here's my example here. So now what this looks like, if this is our example, 1, 2, 3, size 3, capacity 3, is that now capacity, we said, hey, we don't have any capacity for an additional value. So we doubled it, capacity is 6, and then we added those placeholders. So if the last element is at capacity, is not at capacity, it's at capacity minus 1, then the way that we would put that element in there would not be self.size. And I'm curious, this is what's tripping me up about using zeros as like placeholders is, yeah. So even though there's placeholders, it's weird. We're still pretending that the length of the list is like the same as the size. So like there's a capacity to add more values, but if we push, then what does pushback say? To the end of the array. So self.array technically has these values at the very end. I am just going to put the value at self.size. So like self.size is 3, right? So 0, 1, 2, 3 then becomes at the end of where we have values. And then these are still placeholders over here. So if I say self.array is equal to bracket self.size is equal to n, then that should push back this element to the end of the array, even though technically the way we're doing our capacity, the end of the array is like after all these placeholders. So that might come back to bite us in terms, well, we'll find out. We're going to implement pushback in a way that gives us the last element, not the last element, like placeholder element, but the last like actual value that was either inserted or pushed into the array. So this, just a brief overview of this solution. This is based off the solution that this guy wrote. This is not exactly how I would have done it, but I think this is probably closer to the actual implementation of a array list or a vector in Java or C++. So let's do the pop back. We're going to run some tests here in a little bit, and we'll be able to clear up any potential issues with our current implementation. Or we'll just get really confused. We'll see. So pop back will push the element into the end of the array. That is not the right one. Pop back. Turn off that alarm, sorry. We'll pop and return the element at the end of the array. Assume that the array is non-empty. Okay, so we can assume that there's at least one element in the array, size of 1, right? And we're going to pop and return the element at the end of the array. So 2 things need to happen here. We need to adjust the size, right? Not the capacity, just the size. The size is the number this is the big thing to remember. The size is the number that keeps track of the actual elements, like valid elements inside of the array. The capacity is just how many elements we can put in at any given point. And I think that's more of like a memory allocation thing, which, with higher level languages like Python, that's not something we even think about. So we're going to adjust the size, and then we're going to return the value. Well, let's go ahead and finish that sentence. We'll adjust the size by decrementing by 1, and then we'll return the value at the new size, and we'll see how that works. So let's go to the end here, and let's say something like self.size minus equals 1. So this is the same as self.size is equal to self.size minus 1. And then we're going to return the value at the new size. So we're going to do self.array bracket self.size return. All right, there's like an additional step that I might do just to remove any confusion for myself. But let's say that we have 0, well, 1, 2, 3. And so the size, of course, is 3. And if we make the size 2 and then we return the value at 2, we end up saying, okay, there's 2 values inside of here, but if you do value at index 2, 0, 1, 2, that actually returns the value at the value here. Now, the other thing that we could potentially do is like turn it back into a placeholder. Because this isn't actually deleting the value, right? It's just changing the quote unquote size. Again, this is kind of a weird question, but so let's go ahead, and we can't return it right away. So we'll say something like pop value is equal to self.array self.size, and then we'll say self.array self.size is equal to 0, just making it like one of these placeholders. And then we're going to return the popped value. So then what happens here is we're returning 3, but because the capacity in this case is still 3, that just becomes 0, which is our little way that we're doing placeholders here. Okay, so the last 2 things here are get size and get capacity. So get size should just return self.size if I'm not mistaken, because we've been tracking it this whole time, right? So then, oh, by the way, when we did a push up here, we said if the self.size is equal to self.capacity, self.resize, and then self.array at self.size is equal to n. So that adds that value into the end, and then self.size plus equals 1 to account for that new value that exists there. That should do it for pushing, popping, resizing. So then now that we're keeping track of the size, which by the way, when we pop back, we do decrement the size, right? So that also keeps track of the size. So at any given point, we can do a get size and get the current self.size. And that will return it to the outside world. Now get capacity is similar, right? We've been tracking the capacity. So we should just be able to return self.capacity. And if we want to, technically, wherever the heck I put that up here, instead of checking the internal values here, self.size, self.capacity, you could do like a self.getSize, self.getCapacity. But again, because this is, these values aren't being like returned out to anybody, I'm not too concerned with it. These are just getters, and they're essentially doing the exact same operation. So I'm going to leave it alone. And gosh, let's just run some tests and see if this works. Let's go ahead and submit this and see if it passes our tests. Oh, that's so frustrating. All right, so we passed most of the tests. So here, list assignment index out of range. So something that we're calling is not working. And this is going to be probably, we have a pushback, and a pushback. So just a bunch of pushbacks. And apparently, is this the first time that we call pushback? I'd be surprised. No. Interesting. So this is saying, give me a capacity of 2, push 0, push 1. So you could have 0 and 1. Then when you do a pushback of 2, this is where things might be getting messed up, is it would do a self.resize. Then it would get the size. The size would be 3, the 0, 1, 2, 3. Or sorry, the 0, the 1, the 2 would be 1, 2, 3. And then the capacity would be 4 because the original capacity was 2. So when we did this third one, it doubled from 2 to 4. Right. So here it says, hey, if size, which is 2, is equal to capacity, which is 2, which it does after these two operations, then self.resize. And so with the resize is saying self-capacity is equal to 2 times self-capacity. So 2 times 2 is 4. New array is 4 zeros. And then iterate over self-array. And then new array at 0 and 1 should equal to each of those values. And then self array is equal to new array. So new array should equal to 0, 1, comma 0, 0. So let's go ahead and print what's happening. Self.array here and see if we can get it to print anything. Oh, that's annoying. It's not going to give us any output. So for debugging, this is a little tricky. Let's think about this. List assignment index out of range. The list assignment, I'm doing a list assignment here, but then I'm also doing one here. On self array, I'm doing a self.size is equal to n. The size originally started at 0. I did the original push. I pushed at 0, and then I incremented by 1. So then when it pushed again, I pushed at 1, and I incremented to 2. When I did the resize, you don't do anything with the size value. So still 2. All right. They're not really giving us the ability to debug here. So we're going to go ahead and do it over here. We'll open up an IPython instance and we'll debug it in the terminal. I turned off my AC to record this. It is so hot inside my office right now. It's ridiculous. So it just makes it that much more difficult to solve problems like this, but that's okay. Okay, so now we have this dynamic array, right? And the capacity, let's just look at the input values here. So the capacity on this one is 2. And we'll just call this D. If we look at D, we can do like a D dot get size, should be 0. D dot get capacity, should be 2. Cool. So then we do a D dot pushback. And the first value that we push back is 0. Okay. And that doesn't return anything. So we could do a D dot get at 0. And that should give us a 0. Fantastic. So then we do a pushback at 1. And we do a get at 1. And it gives us a 1. Okay. So we're good here. So then we do a D dot get size, which should be 2. And we do a D dot get capacity, which is also 2. That's interesting. We haven't, okay, so the one thing I didn't do is the last pushback, which is what probably breaks the code. So let's do that. Let's do a D dot pushback. Whoop. There we go. 2. Sure enough, not the exact same error, but pushback, if size equal to self.capacity, I gotta look at it over here. I can't read it over there. This is inside of what pushback? Self.resize. Okay, and then in self.resize, line 40 apparently. New array I. Oh, there's my problem. God. I wanted to be more explicit and call this index here, but then because we've been using the term I elsewhere, I didn't update it. So that is annoying, but hopefully that was our only mistake. Yes, it was. So just some quick debugging over in our IPython terminal over here in this interpreter. And we were able to discover that I had a silly little typo. Okay, we're passing all the tests. Let's just do a brief overview because this was a lot for something that really should have been pretty simple. They have the class, they give us all the pre-made all the empty methods, and then we just fill them in. So we have our dunder init, we've got our get, our insert, our pushback, our popback, our resize, our get size, and get capacity. The init is going to initialize a attribute called capacity to the argument capacity, which is an integer value. And then we initialize size to 0. So this is our variable, our attribute for keeping track of size on this object. And then we do array is equal to, and we just use square bracket 0 times capacity to basically create not an empty list, but like a list with placeholders that are zeros. And again, I think if we get rid of this, it probably breaks. I could be wrong. Yeah. Okay. Yeah. So you do need, the way this implementation works, you do need to have those placeholders. You can easily do this. You don't forget that 0 inside there. You can easily do this in all 4 languages, as far as I know, for sure in JavaScript and Python. Alrighty. So then when we want to get a value, we simply just return the value at the index I. You could technically do a loop if you didn't want to use the square bracket notation. You wanted to like really do it from scratch, then you could just put like a simple loop in here, and whenever you get to that index, you can return that value. Insert will insert the element in an index I, assumes the index I is valid. So again, we're just overriding the value at index I with the value in that gets passed into this insert method. And yeah, this is what threw me off. The use of I and get and insert as predefined arguments. I tried to use something more verbose and different down in my implementation of whatever it was, the resize, and that threw me off because I did not make those variables match. So speaking of pushback, we first have to, based on what we have here, it says it should resize the array if pushback is called, but the array is full. So the first thing we do is say, hey, is the array full? Is the size equal to the capacity? If it is, then just invoke this resize that we defined later on. So we'll look at that resize method in a minute. Then we say, okay, give me the value at self.size, and instead of giving it to me, actually override it with whatever values passed into pushback available through the argument variable in. We've just added a new value, a new element to our array. So we increase our size by 1. This is how we keep track of our size. This will be helpful later, right? Because we need to be able to get the size in our get size method. Pop back is going to be the equivalent of like a pop in JavaScript or even a pop in Python. I guess a lot of languages call it pop, but basically give me the last element, but also remove it from the array. And so we say decrement the size. And then because indexes are 0-based, you can give me the element at self.size after it's been incremented or decremented rather, and that will be that value, right? If you call the value at self.size on a regular list that doesn't have those placeholder values, then you're going to get an index out of bounds error. Here we have the placeholders in the event that the capacity is higher than the current size count. In any event, the way that we're doing it is we're decrementing the size. We're getting the popped value at the self.size index. So we're using the size as the index in this case because we've decremented it back 1 value. So now it's in line with that 0-based indice or index. And so then self.array, self.size is equal to 0. This is just the extra step I took. You don't have to do this. Again, I think if you commented this out and you submitted it, it would probably pass all the tests. Yeah, it does. I just want it like in my brain, OCD, I'm like, well, if we're using a bunch of placeholder values as zeros, then if we remove an element, then we should probably put a 0 in place where that element is. And so that was my line of thinking. Either way, we return the pop value. So this is kind of like a soft delete. We go ahead and return the pop value, and the size has been decremented. So those are like the two requirements: decrement the size, return the value at the size. The resize, of course, is going to double the capacity. I got hung up on this the first time because my brain just wanted to solve it on its own. It was like, oh, if you're resizing, just increment by 1 to allow space for an additional element to be popped to the end of the list, or sorry, to be pushed to the end of the list. Not the case. They specifically say double it. When you resize, double it. So attention to detail is super important. So in the resize, the first thing we do is we take the current capacity and we set it equal to itself times 2, and that doubles it. Now we're going to update the existing array to have those placeholder values to take the place of all the additional available capacity spaces. And so we do that here. Index value, enumerate, self-array. The new array at the current index is equal to the value at that index. Ultimately, once this new array has been updated with values from the existing array, then we can overwrite the existing array with the new array. Get size, simple. We just return self.size. Get capacity, same thing, easy. We just return self.capacity. And that's it. So yeah, it's definitely easy. On the easy side, the first time I did this problem, I wanted to use a bunch of built-in array methods from JavaScript and built-in list methods from Python, because JavaScript array and Python list are dynamic arrays. They already have all this functionality. So that's kind of cheating, right? You don't, if the problem is to implement these things, you don't want to use those things to solve the problem. So the second time around, tried to go closer to the solution, which if you look over at the solution, you can see for Python, his is very similar to mine. I don't think that he, on the pop back, updated the value that gets popped with a 0. He does check to make sure that the length is greater than 0, but I could have sworn that in the question for pop back, it says you can assume that the array is not empty. And so checking the length, why is he, oh, self dot. Okay, I called mine size, he called his length. In any event, he's doing a check on the pop back just to make sure that the size is greater than 0. Either way, they tell us that the array is not empty, so I wasn't really worried about it. That's my solution. I want to turn my air conditioning on. Hopefully you enjoyed something here. Try doing this on your own, or try doing this first. I guess it's too late to say that, but hopefully you did this first and then now you're watching the solution video. Anyway, thanks for watching. We'll catch you all in the next one. See ya.